Now, let's begin the solution to the question 1. From the question 1, we should do the two things. The first thing is prove the probability of A assuming B naught plus the probability A naught assuming B equal 1 if A and B are independent. And the second thing is prove A and B are independent if the probability A assuming B naught plus the probability A naught assuming B equal 1. Now let's begin the first thing. From the definition of conditional probability, we can know that the probability A assuming B naught equal the probability A B naught over the probability B naught. And the probability A naught assuming B equals the probability A naught B over the probability B. Because A and B are independent, A B naught are independent. Also, A naught B are independent. And then we can know that the probability A B naught equals the probability A times the probability B naught. Also, the probability A naught B equals the probability A naught times the probability B. And from the above the function, we can get the probability A assuming B naught equals the probability A B naught over the probability B naught. And the probability A B naught equals the probability A times the probability B naught. And B naught cancel. So at last the probability A assuming B naught equals the probability of A. At the same way, the probability A naught assuming B equals the probability A naught. Then we can get the probability A assuming B naught plus the probability A naught assuming B equals the probability of A plus the probability of A naught, then equals 1. Then the first thing is finished. Let's begin the second thing. Here's the function of the probability of B equals the probability B S, and S equals A and A plus the A naught. Then we can get the probability B times A plus A naught. From the distribution, we can get the probability A B plus the probability A naught B. Then we can get the final function, the probability B equal the probability AB plus the probability A naught B. From this function, we can get the probability AB equals the probability B minus the probability A naught B. And then from the conditional probability, we can get the probability B minus the probability A naught assuming B times the probability B. Because they have the same probability of B, so we can take together and get this 1 minus the probability A not assuming B, and then times the probability B. From the contradiction, the probability A assuming B naught plus the the probability A naught assuming B equal 1, we can get this, and we can get this. You can get this, and this function can turn out to be the probability A assuming B naught, and times the probability B. Then we can take the probability B to the left side. We can get the probability A assuming B naught equal the probability A assuming B. And because the same function, the probability of B equals the probability AB plus the probability A naught B, we can get the same function. The probability A equals the probability AB plus the probability AB naught. And from the definition of conditional probability, we can get this function. Probability AB equals this one, and probability AB naught equals this one. Then we can, because the probability A assuming B naught equals the probability A assuming B, we can get together, take out and plus, and let the probability B plus the probability B naught. This one equals the 1, so the probability A equals the probability A assuming B. And at the last, we can get the probability AB equal the probability A assuming B times the probability B. And probability A assuming B equals the probability of A. So we can get the probability A times the probability of B. And then we can get the final conclusion. A